Section 3-4, Part 2. Some expressions containing exponents include a different relationship, so they require a different property to simplify. Let's look at this problem. Simplify the expression 3/5 inside the parentheses raised to the higher power of 4. Remember our rule. Anything raised to the fourth power says that we can write it down and multiply it times itself 4 times. 3/5 times 3/5 times 3/5 times 3/5. That's what happens when you raise anything to the fourth power. Write it down 4 times and multiply it. Well, if you multiply like bases, you add exponents. So that's how I got 4. 1 plus 1 plus 1 plus 1 gives you 4. And if I multiply 5 to the first times 5 to the first times 5 to the first times 5 to the first, that's 4 5s would be 5 to the 1 plus 1 plus 1 plus 1 is 5 to the fourth. So when you're multiplying like bases, you add exponents. We can also look at this problem in a different way. We can look at it in the relationship of a power to a power. When you have 3 to the 5th raised to the 4th power, each number individually is raised to the 4th power. 3 to the 1st is raised to the 4th power. 5 to the 1st is raised to the 4th power. Well, when one exponent's inside and one exponent's outside, you multiply them. 1 times 4 gives you 4, and 1 times 4 gives you 4. So you see, either way you look at it, your final answer is 3 to the 4th divided by 5 to the 4th. So let's look at our rule. Power of a quotient. To find the power of a quotient, raise the numerator and the denominator to the power and simplify. The arithmetic way, raising each one to the 4th power, 3 to the 4th and 5 to the 4th. I went ahead and raised them to the powers. 3 to the 4th is 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. 5 to the 4th is 5 times 5 is 25. Times the third 5 is 125. Times the fourth 5 is 625. Use your calculator to raise those numbers to the powers. The algebra formula, AB raised to the nth, says you're raising each term, the numerator to the nth power, the denominator b to the nth power, where a is not 0 and b is not 0 and n is an integer. So let's look at some problems using those rules. Simplify expressions with division and exponents, simplifying the expression. This is topic 3-4, part 2. 3-4, part 2. So what I'm going to do is I'm going to take, in this problem, a to the 7th divided by 5, and I'm going to raise each one individually to the 3rd power. I'm going to take a to the 7th, put parentheses around it, and raise it to the 3rd power. Divided by. I'm going to take 5 to the 1st power and raise it to the higher power of 3. I raise the numerator to the 3rd power, and I raise the denominator to the 3rd power. Multiply those exponents when one's inside and one's outside. 3 times 7 gives you 21. A to the 21 divided by 1 times 3 gives you 5 to the 3rd. We can expand that on out. A to the 21st stays in the numerator. The denominator is 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. So my final answer to this problem is A to the 21st divided by 125. Let's look at B part. Looking at this example. 2x cubed divided by 3y, all being raised to the 2nd power. I'm going to take each one individually and raise it to the second power. I'm going to take 2 and raise it to the second power. I'm going to take x cubed and raise it to the second power. Multiplying those together, divided by. Take the denominator 3 and raise it to the second power. Times take y to the first and raise it to the second power. Now this is y to the first. Every number, every letter has an exponent. If you don't see it, it's understood to be a 1. So 2 squared, that's 2 times 2, gives me 4. Now, here, both of these are exponents. You multiply them when one's inside and one's outside, one being raised to the higher power of the other. 3 times 2 gives you x to the 6th. Divided by 3 squared. That's big 3 times big 3 gives me 9. Y1 squared. They're both exponents. That's when we use our rule. We multiply 1 times 2. 1 times 2 gives you y squared. So your final answer in this problem is 4x to the 6th divided by 9y squared.